In this lecture, we're going to review the concept of absolute value. I bet you remember how to find the absolute value of a real number, and we are going to review that, although we're going to do it with a really nerdy definition that's going to make it look more complicated than it actually is. But once we've gotten that basic review out of the way, we're going to do some next level things with absolute value. We're going to simplify absolute value expressions, and we're going to talk about how you can use absolute value to describe the distance between 2 points on the number line. First, that nerdy definition. The absolute value of a real number A, denoted by putting the A inside of a pair of vertical line segments, so we read this expression, the absolute value of A, is defined in the following way. If the number A that you're looking at is greater than or equal to 0, that is, if it's non-negative, then the absolute value of A is just itself. This is the rule that you know. I've written it in a very nerdy way, but the idea is easy. If the number you're looking at is non-negative, greater than or equal to 0, then the absolute value of the number is just itself. If the number is negative, the way that we usually say the rule is you make the number positive, right? That's the way that we think of absolute value. When you take the absolute value of a negative number, it makes it positive. When you look at this nerdy rule, it almost looks wrong at first, but you have to remember what it says. This says to find the absolute value of A in the case where A is less than 0, you negate A. It doesn't say make A negative. A common way to read this symbol is to say negative A, and I normally wouldn't pick on that, but here I think that's going to give you the wrong idea, because it makes it sound like the answer is negative, and you guys probably know the absolute value of a number can't come out negative. That's why we don't want to say this as negative A. Think of this as the opposite of A. So it doesn't say make the number negative, it says find its opposite. Well, we're starting with a negative number, so if we find the opposite of that, that number will be positive. Here are some real number examples. The first example will illustrate my point. It says find the absolute value of negative 7. Now, you know that answer is 7, but let me show you how that integrates with the rule that we just wrote. So to find the absolute value of a number, we first determine what case we're in. Our A is less than 0 because in our example, our number is negative 7. The rule says take the opposite of that number. So according to the rule, I take the opposite of the input, and the opposite of negative 7 is 7. Now, don't misunderstand me here. I don't expect you to show me this step. I don't think that's a necessary step. What I'm trying to do is explain how the rule works. The rule says if the input is less than 0, then its absolute value is its negation, or its opposite. And so we found the opposite of the input, and that gives us the answer that we know is right. The absolute value of negative 7 is 7. Now, you might wonder why we would come up with such a nerdy rule when there's an easier way to explain it. And the basic idea is that we want to avoid ambiguities later when we have more complicated problems. Sure, there's a shortcut way to describe the answers here, but later when we're dealing with more complicated expressions, we're going to need that formality to help us through. And you might know the answers to the rest of these, but I just want to walk it through from the perspective of the definition. The second one says the absolute value of 0. Going back to our rule, we're in our first condition. If A is greater than or equal to 0, the absolute value of A is just itself. So since this input is greater than or equal to 0, we just recopy it. The absolute value of 0 is 0. 4 is also greater than or equal to 0, so it falls under the same rule. The absolute value of 4 is 4. And I put in this last one just to remind you an order of operations issue. To find the absolute value of 3 minus 5, if you're going to follow the order of operations, you would start by doing the subtracting. A common misconception is that absolute value bars magically change all minus signs into plus signs. That's not what the rule says. It says if the input is greater than or equal to 0, you leave it alone, and if the input is less than 0, then you find its opposite. The rule doesn't say change minus signs into plus signs, right? There's that formality. So the absolute value of 3 minus 5 by the order of operations would be found by first doing the subtraction inside of the grouping symbols. And now we've reduced this to a case that the definition can handle. The absolute value of a number less than 0 is found by taking its opposite, and the opposite of negative 2 is positive 2. Note that I didn't write that extra step where I negated the number because I don't think that's necessary. I only put that in the first one to show you how the rule works. Let's look at a few more real number examples, but a little trickier. The first example here says the absolute value of 4 minus pi. That's a real number written in its simplest form because pi is what we call an irrational number. It's a non-terminating, non-repeating decimal. We can't come up with an exact decimal representation for this because pi goes on forever and ever. This 4 minus pi is the best way to write this. It's the closed form of the number. But we can still find its absolute value. We just have to refer back to the rule. The rule says that if the input is greater than or equal to 0, the absolute value of the number is itself. And if the number is less than 0, then its absolute value is its opposite. So the question is 4 minus pi greater than or equal to 0, or is it less than 0? That is this non-negative or is it negative? Well, I think most of you know that pi is pretty close to 3.1. That's a common approximation for pi, 3.14. It's certainly less than 4. And 4 minus a number less than 4 would be positive. 4 minus pi itself is positive. What's the rule say to do with a positive number? Well, if a number is greater than or equal to 0, its absolute value is just itself. So the absolute value of 4 minus pi is 4 minus pi. Here's an upper level example where we used the rule. First, we determined whether 4 minus pi was positive or negative, and then we applied the rule. Notice that it did not change to 4 plus pi. Again, absolute value bars don't change minus signs into plus signs. That's not their job. You want to know their job? Here's their job. Written in a nerdy way, but we want this nerdy way so that we can cover any ambiguity, so that we can do these upper level kinds of problems. What about the absolute value of pi minus 4? Well, we said that pi is smaller than 4, so pi minus 4 would be negative. Pi minus 4 would be less than 0. And the rule says that we are to negate that input. Here's a perfect example of where we want this nerdy rule. We're going to negate the input. Now, how do I show that I'm negating that input? This wouldn't be right. I didn't negate the input when I write it like this. I've only negated the first term. To show that I'm negating the entire input, I need parentheses or brackets, or if you're really strange, you could use those curly braces. Most of us would use parentheses as our grouping symbols here. And this is a perfectly acceptable answer. There's nothing wrong with this as an answer. However, it wouldn't be considered simplified. To simplify it, I would distribute and write it as negative pi plus 4. And then even I would write it as 4 minus pi after that. I would switch the order. But any of those are a correct answer. If the instructions don't ask you to simplify after you find the absolute value, there's nothing wrong with those. All three are correct. The last one uses the fewest number of symbols, and so it's kind of the cleanest way to write it. What I'd like you to do is pause the video and try to do the same thing for the last one. The last one says the absolute value of 1.7 minus the square root of 3. Now, the square root of 3 is another irrational number. You might not be familiar with it. It's certainly not as commonly known as pi. So let me give you a decimal approximation for the square root of 3 here. The square root of 3 is around 1.732. What's important there is notice that the square root of 3 is bigger than 1.7. Using that, see if you can simplify the absolute value of 1.7 minus the square root of 3 to an expression that doesn't have absolute value bars. Okay, as we said, 1.7 minus the square root of 3 would be negative because the square root of 3 is bigger than 1.7. And how do we find the absolute value of a negative number? We negate the input. So we're going to negate the expression inside the absolute value bars. That distributes a negative to both terms. So this becomes negative 1.7. This becomes plus the square root of 3. And then I would reorder that. I would rewrite this as the square root of 3 minus 1.7, and that would be our answer. This is no different than the rules that we used on the previous slide. These are just more complicated examples because you have to take a second to determine whether the input is positive or negative. Okay, now let's take these a step further. Rather than starting with a real number, we're going to start with an algebraic expression inside of the absolute value bars, but with a condition that will help us determine how to simplify it. This first example says, rewrite the following expression as an equivalent expression without absolute value, and the expression is the absolute value of 5 minus x. On its own, we cannot simplify that expression because we have no idea what the value of x is. However, we've got this condition off to the right that says we are to assume that x is greater than 5. Using that, I can simplify this because it turns out that when x is greater than 5, this expression will always have the same sign. How do we determine the sign of that expression? You can do it with intuition, with a little bit of number sense, or you can do it very formally. I'll show you both. First, using intuition, just pick some numbers greater than 5, like 6. 6 is bigger than 5. 5 minus 6 would be negative. Pick another number bigger than 5, like 8. 5 minus 8 would be negative. Pick another number greater than 5, like 5.1. 5 minus 5.1 would also be negative. It appears that if we pick a number bigger than 5, we're going to get a negative expression inside the absolute value bars, because 5 minus a number bigger than 5 would always be negative. So our rule says that the absolute value of 5 minus x will be equal to the negation of 5 minus x because the input is negative. When x is greater than 5, 5 minus x is negative. So the absolute value of 5 minus x in this case would be the negation of that expression, and that would distribute the negative to both terms, and then I would switch the order and I get x minus 5. And you can see that this would work if you pick a specific input. For example, pick 6. The absolute value of 5 minus 6 would be the absolute value of negative 1, which is 1. And what do I get when I plug 6 into this expression? 6 minus 5, it's 1. If I check that with a specific value, I can see that it works. I plugged the input into the original expression, simplified it. I plugged my input into my new expression, simplified that, and I got the same answer. So I promised you 2 ways to make this determination that the input of 5 minus x is less than 0. The first way, we just did it with number sense. We just guessed some numbers, but we can do it a more formal way. I'm starting with the expression x is greater than 5, and I want to learn something about 5 minus x. So if I start with the expression x is greater than 5, then I can simplify it by subtracting x from both sides. Now, why would I subtract x from both sides and not subtract 5 from both sides? Well, the expression I'm trying to create is 5 minus x. On the left side, I get 0, x minus x is 0, and on the right side, I get 5 minus x, which is the very expression that we're trying to investigate. Well, this says 0 is greater than 5 minus x. Another way to write that is to flip the order of the inequality. So put the 5 minus x on the left, put the 0 on the right, and then flip the inequality so that the fish or the alligator or the Pac-Man or whatever it was when you were in first grade is still trying to eat the 0. This says 5 minus x is less than 0. Exactly what we said when we did it the less formal way. So you can either make that determination using some guesses, some number sense, or you can actually do it more formally by creating the expression that you were going for. Now that we've determined that 5 minus x is less than 0, we would apply the exact same rule, get the exact same answer, and perhaps check it with an input. Let's rewrite the expression absolute value of a minus b if a is greater than b. You can rely on your number sense again here if you want to. In my opinion, I think it's easier to do it more formally. I'm going to start with the condition a is greater than b, and I'm going to create this a minus b. So how would I create a minus b? Well, the obvious thing to do is to subtract b from the left side. That'll create an a minus b, and of course, in order to balance that step, I have to subtract b from the right side. That gives me the a minus b that we want on the left side. B minus b is 0. And we see that in this condition, a minus b is greater than 0. That means that a minus b is positive. And so to find the absolute value of a minus b in this situation, I just leave it alone. The absolute value of a minus b is a minus b. Pick any 2 numbers where the first number is bigger than the second number and plug them in, and you'll see that this rule works. I'd like you to try to do the same thing for the other situation where a is less than b. Pause the video and give this one a shot. Okay, you might not have needed to run through the formality because you can use the previous example as a guide. You know that this is going to be the opposite scenario. But I'm going to show all the steps. So I'm going to start with the fact that a is less than b. That's our given condition. And I'm going to create this a minus b by subtracting b from both sides. It gives me the a minus b that I was aiming for. And b minus b is 0. And now we see that a minus b is less than 0 in this scenario. And so the absolute value of a minus b in this scenario would be its opposite, its negation. And I would distribute that negative to both terms, and then I would flip the order, and I would write this as b minus a. If a is less than b, then b minus a is going to be positive, and we'll get a positive result just like we expect. Unlike the numerical examples, these variable examples take a little bit more thought. If it doesn't feel immediately clear, that's perfectly understandable. That's normal. You might have to go through examples like this a couple of times, try some on your own before it really starts to click. Again, my advice is take the condition and try to form the expression that you're interested in. Use that to make your comparison. Once you've made that comparison, then go back to our formal rules and they'll tell you what to do. If the expression you're looking at is greater than or equal to 0, leave it alone. Just drop the absolute value bars. And if the expression you're looking at is less than 0, then when you drop the absolute value bars, you must find the opposite of the input, and then you can simplify that if you want to. Again, I like to simplify it all the way down as far as I can, but there's nothing in here that says that you have to simplify when you're done, so leaving it as the negation of a minus b was perfectly fine. I just can't handle that. At some point in my mathematical career, I must have been beaten down by somebody who said I had to simplify everything, so I still do. But I'm also a fairly literal person, and when it says rewrite it as an equivalent expression without absolute value bars, we've done that here. You don't have to write anymore. Let me move on to an example where I would just use my number sense instead of doing it the more formal way, and the reason is because of a lack of a condition. It's not to say that we can't do this one by doing it the more formal way. I just personally would not. So here we're rewriting the expression absolute value of x squared plus 4. So in my head I would say, okay, when I square a real number, that's going to be non-negative. The smallest x squared can be is 0 when the input is a real number. So the smallest x squared plus 4 could be is 4. Well, that's positive. X squared plus 4 is guaranteed to be positive for any real number input. We know that the absolute value of a positive number is just itself, and so I get that the absolute value of x squared plus 4 is just x squared plus 4. We don't need a condition here because x squared plus 4 is always positive. It doesn't matter what the input is as long as it's a real number when you're not dealing with those pesky imaginary numbers. You could do this a more formal way. You could start by saying that x squared is greater than or equal to 0 for all real values of x, and then you could create the x squared plus 4 expression by adding 4 to both sides. And if x squared plus 4 is greater than or equal to 4, then it's certainly positive, and then you come up with the same result. I would just use my number sense. I don't care which way you do it, formality, number sense. Try to rewrite the expression absolute value of the difference of negation of x squared and 1 without absolute value. Okay, let's see if you got it. If the smallest x squared can be is 0, then the biggest the negation of x squared could be is 0. Then we're going to subtract 1 from that, so the biggest this expression could be is negative 1. The negation of x squared minus 1 is always going to be negative. Another way to see that is that x squared plus 1 would always be positive. So if we negate both of those, remember that we have to flip the direction of the inequality, and that will be negative. When you take the negation of a negative number, you negate the entire expression. That's going to change both signs. And I think it's examples like this that make people think that absolute value bars magically change all minus signs into plus signs. But we've seen plenty of times that that's not true. But perhaps this is where they get that impression, because it does happen in certain instances. And I'd like to reiterate, when you're trying these, if you're not sure if your answer is right, just pick a value of x and see if it works. So that's one application of absolute value that maybe you've never really seen before, is rewriting these absolute value expressions. Another thing that we use absolute value for is to express distances. This application you may have seen before. In fact, you may have been taught that absolute value is defined in terms of distance. Oftentimes, we're taught that the absolute value of a number is just its distance from 0, right? When we say that the absolute value of negative 7 is 7, that's because on the number line, negative 7 is 7 units away from 0. The distance is 7. You may have heard this before. Absolute value can be defined in terms of distances. Our definition doesn't work that way, but that's a perfectly legitimate way to define it. Instead, we're going to use absolute value to describe distances. We already have our formal definition, and now we're going to use that to help us describe distances between points. For our first example, we'll express the distance between 4 and x as an absolute value expression. Let's take that number line approach here and see how we would do this. So here's the number 4, and then I've got some number x, and I don't know where it is. It could be bigger than 4, it could be less than 4. If x is bigger than 4, well then this is easy. We just do x minus 4. Like if x is 7, the distance is 3, because you do 7 minus 4. And if x is 9, well then the distance is 5, because you do 9 minus 4. So at first glance, it seems like the answer should just be x minus 4. But there's a problem. What if x isn't to the right of 4 on the number line? What if x is on the left side? Now x minus 4 doesn't work because the distance can't be negative. You can't have a negative distance. So we need an expression that when x is bigger than 4, we do x minus 4. And when x is less than 4, we do 4 minus x. Or another way to say that is, we do x minus 4 and then we negate it. If only we were studying some expression that when the input was positive, you leave it alone, and when the input is negative, you negate. That's exactly what we're talking about, absolute value bars. How do I make sure that this comes out non-negative? I slap some absolute value bars around it. Does that really solve our problems? Sure. If I pick a number that's less than 4, like say 2, the absolute value of x minus 4 would be the negation of x minus 4. Like when I plug 2 in there, 2 minus 4 would be negative 2, and the absolute value of that would be 2, which is the distance that we want. So the absolute value of x minus 4 is the distance between 4 and any real number x. The absolute value bars are there to make sure that we get a non-negative result. The distance can't be negative. Let me show you another one with a different starting point. The distance between negative 2 and x. Same idea. If you want, you can test yourself by pausing the video, but I did this one because the answer comes out slightly different looking. So negative 2 lives somewhere on here. And if the input I pick is bigger than negative 2, then I want to do x minus negative 2. But the input could also be on the left side. And if the input's on the left side, then x minus negative 2 is going to come out negative. To make sure that I don't get a negative result, I slap absolute value bars around this, and I'm done. And that answer is technically correct. But the reason why this one comes out looking different is that I can't leave the answer like that. Minus negative 2 can be rewritten as plus 2, and I would rewrite that. And now again, don't fall into this trap. A lot of people will look at this x plus 2 and be like, well, there's already a plus sign, so I can drop the absolute value bars. There's two things wrong with that. One, that's horribly incorrect, because if x is less than negative 2, then the result in here will be negative. And secondly, the instructions specifically say that the answer should be written as an absolute value expression. So even if there was part of you that believed that x plus 2 is always positive, which it isn't, but even if you believe that, the instructions specifically say to write your answer as an absolute value expression, so you don't want to drop the absolute value bars, even if you feel like you can. This one looks funny because we said that we subtract to find distances, but this one has a plus sign. It has a plus sign because of the simplification of subtracting negative 2. So one last one for you to try. Express the distance between A and B, two variable expressions, as an absolute value expression. Pause the video and see if you can come up with that. Okay, here we have no idea if A is bigger than B or B is bigger than A. How do I get around that? Well, I'm going to subtract them in some order. I'll do A minus B. And if A is greater than or equal to B, that's perfectly fine. If A is less than B, then this comes out negative. I need to make sure that those negative differences get turned into positive distances. And how do I make sure that the negative numbers become positive results? Well, I slap absolute value bars around that. That won't affect anything if A is greater than or equal to B. But if A is less than B, those negative results become positive. There's another perfectly legitimate result here, and that's to do B minus A first and then take the absolute value. Either of these would be correct. We could have also done that in the numerical examples, but it's kind of traditional to write the x first and the number second. We could have, though, written 4 minus x here and then slapped absolute value bars around that. That also would have been correct. To me, that looks funny. There's nothing wrong with it. That's just my own little peccadillo. I personally wouldn't write it that way, but it is correct. We could have done that in this example. Okay, so we talked about a more formal definition of absolute value, and we applied that more formal definition to some upper level ideas that some of you are going to be running into in the future. The basic concepts of absolute value are very straightforward, but sometimes absolute value problems can be a little more complicated. You ran into something similar with absolute value in beginning algebra, where finding the absolute value of a number is easy, but solving absolute value equations and inequalities takes a little more work. If you have any questions for me, just reach out, email, find me in an office hour.